Hello everyone and welcome back to the Kohi Game Engine series. Today we are going to tackle loading textures from disk. I would like to take a quick second and thank the supporters of the channel, beginning with our partners Eearslya, Wensheng, and Caden. They are the partners of the channel, which is the highest tier of support for the channel, so thank you very much for that. And I would also like to thank all the other supporters listed here on the screen. Your support is very much appreciated, so thank you for that. So this process is going to be relatively quick, at least by comparison to the last two videos. So what we want to accomplish this time is we want to be able to load a file from disk of a certain type, right? We'll say PNG, for example. And we want to be able to load that as a texture and be able to present it onto our geometry, right? Because right now we're just using one that we generate in memory, but a more practical application obviously is to load textures from disk. So we're going to accomplish that, and then we're going to take it one step further and actually create a little bit of logic that allows us to sort of swap that texture out on the fly and load in a new texture to sort of test out our generation code. Okay? And so the very first thing that we're going to need is we're going to need some images to actually work with, right? So I have open here my folder, my assets folder within the Kohi project. So we have shaders in here, and that's the only thing that we have, right? So next to that, I'm going to create a new folder, and I'm just going to call this textures. And in that, I'm going to paste a few images. Now, these particular images are ones that I grabbed from OpenGL. So these are just freely available on the internet, so I don't have an issue with sort of providing these. So if we change our view here a little bit, let's go with extra large icons so you guys can see what we're dealing with. So we've got this cobblestone texture, a paving texture, and then sort of an alternate paving texture. And these aren't, you know, necessarily super high quality images or anything like that, but they're different enough for our testing purposes, right? So these are the images that we're going to use. These will be available in the repository once this is actually released. You guys, of course, can swap these out for any images that you want to. Okay, so that is it, at least for the assets that we'll be using, okay? Next, we need to import a header-only library, and this is probably going to be the only library for the foreseeable future that I'm actually going to use. And I know that we're building all this stuff from scratch, but this is an exception that I'm making in this series for the sake of time, right? And I may do a side video as to how all this stuff works and how you might write one of these, but what we're going to be using is something called STB image, which is part of the STB collection of utilities, right? And this is written by Sean Barrett. It's available here on GitHub, and the STB image is the one that we're interested in. And what this is a header-only library that allows us to load lots of different images of different formats, right? And the reason I've chosen this library is A, because it's header-only, B, because it's very light and very quick. C, image loading can be actually a fairly complicated thing because there are a lot of compression algorithms and things that you would need to handle and write. And it's just frankly not really worth doing. Now, we are going to be eventually making our own proprietary image format. So you guys will see how we read and write image data when it comes to that. But I'm not really interested in you know, sort of rewriting decoders for all these different formats, right? That's kind of a solved problem, and I don't think the series would gain a lot by us actually doing that, right? So I've chosen to use this library. There are lots of other libraries out there. I like this one because it's header only, and because we can literally take this source and plop it into a file within our project, and it's ready to use. So what I'm going to do is actually go to Engine, and under the source, I'm going to create a new folder, and I'm going to call this vendor. And this is where we're going to put anything like this, right? And for right now, this is going to be the only library that we actually use. There may be one other thing that we wind up doing in the future, maybe two, where it makes sense. But for the most part, we are going to be writing stuff ourselves. This is just sort of an exception here. So I'm going to create a new file here. I'm going to call this stb image.h. Okay. And I'm just going to paste in, actually, let me get rid of this console here. Right. I'm going to paste in all this code, right? Because this is all the logic that is necessary to decode all these different image formats, right? And it's not really something I'm interested in stepping through in the series. So again, this is a fantastic library. It's already a solved problem. So this is what I have decided to go with. Okay. All right, so that takes care of that. So in our renderer front end, we have a concept of a default texture, right? And this is just sort of our fallback texture for any texture that doesn't actually load properly, right? However, we actually need defaults in a few other places as well, right? Because right now we're just sort of using this default texture as is, which isn't necessarily the best way to do things, right? Because we're going to actually have a few different default textures, right? So this default texture is probably going to wind up being renamed. But what we need is we actually need in our Vulkan types IONL within our object shader, we actually need a pointer to a default diffuse texture, right? Because this is our default, one of our defaults that we need to actually be able to access, right? And so when we create this shader, we're going to wind up providing a pointer to a default diffuse texture. Now this default diffuse texture is going to wind up being our default texture that's provided in the renderer front end, but we could change it, right? So in Vulkan types, I've gone ahead and added a default diffuse texture pointer, right? And this is just going to point to that texture. Also, in renderer types INL, we want to add to our renderer backend structure a default diffuse texture here as well, because we'll want to be able to access this at the renderer backend level as well as at the shader level, okay? So we'll need access at both levels, so we need to store a pointer to that texture at both levels, right? They're going to both wind up pointing to the same texture more than likely, but we need those both, okay? Next, we need to go to Vulkan object shader.h, and we need to modify the create method because we need to actually add another parameter to it right between context and out shader. We want to go ahead and add a pointer to a default diffuse texture. Now, eventually this will wind up being an array of default textures, but for right now we're just going to pass the one, right? And so we've done that here. We also need to go into the C file, and we need to go up here to its definition and place it there as well, okay? Of course, since we are taking that in, we need to actually store it. So the first thing that we're going to do is at the very top, we're going to take a copy of the default texture pointer, right? And in this case, we're just going to save that off to the out shader default diffuse is equal to default diffuse that's passed in here, okay? In Vulkan backend, we actually need to make a couple changes to support this as well. So if we search for our Vulkan object shader create, it now expects a new object as well. So we'll put here backend default diffuse. Okay, and now that passes through as well. So it just uses that same pointer that is on the back end, it passes that through to the shader, and now the shader has a copy of it as well. One more thing in this file is in the create texture method, we actually have a bug in here. So in the last video, I had actually placed the Vulkan buffer destroy here, and this is actually the wrong spot for it. It should not be destroyed there. It should be destroyed after the single use buffer is ended, okay? So that was actually throwing a validation error, so I just put that in the wrong spot, okay? So we just need to move that down there. And then one more minor thing that we should also change is here we are actually getting a pointer to the Vulkan texture data. There are particular cases where we could pass a texture here that maybe doesn't have internal data. So we should actually be checking this to see if that data exists. So we're actually just going to go ahead and fix that real quick as well. And we're going to basically say if data exists, and then we'll wrap all of that logic right up to the 0 memory in that check, so that we don't actually crash if for some reason this returns a null pointer, okay? And that is pretty much it for that bug fix, okay? All right. So one more thing that we need to actually enhance is back in Vulkan object shader.c. When we are updating the descriptors, specifically down here, after we get a pointer to the texture and the descriptor generation, we need to check to see if the texture has not actually been loaded yet, right? And we can do that by comparing the texture generation against invalid ID. So if we get this, what we're going to want to do is we're going to want to use the default diffuse texture instead. We're going to set the descriptor generation to invalid ID, saying that we are actually using the default texture, right? So this is sort of a catch-all to say if the texture is not yet loaded for some reason, then we're going to go ahead and use the default texture instead, right? And one thing that I have here is a to-do to determine which use the texture has, and then pull the appropriate default based on that, right? So right now we only have a default diffuse, but when we start introducing other texture maps, we're actually going to have to revisit this code and say, okay, well, which map do we actually need to get? Which default map do we need to get? The diffuse, or maybe the normal map, something along those lines, right? So we'll need to add some logic here later to actually handle that. But for right now, since we only have that, just the one is fine, okay? All right, so the bulk of the work is actually going to be done in the renderer front end, right? So we're going to go ahead to the C file here, and I'm actually just going to come here to the top, and right below resource types, we're going to insert some temporary includes and defines, okay? So we're going to need our k-string library. We only need this for our experimental code, so I'm putting it within this to-do temporary block here. We're also going to need our event system, because we're going to need a way to trigger the texture loading. Basically, we're going to bind it to a key press, right? Just to sort of illustrate swapping out the textures. So we're going to need event.h. We also need our newly created vendor stbimage.h, and we also have to define this stb image implementation for that. And that's basically saying, if we take a look at this, whoops. So if we take a look at this library here, it specifically says to use stb image implementation unless we want to have to include a C or C++ file. We don't want to do that. We want to just use the header only, so we need to define this, okay? And again, this is all temporary because eventually all these things will be moving to a resource loader, and within that resource loader is where all this logic will actually live. It doesn't belong within the renderer front end here, but since we don't have that yet, this is where I'm putting it, okay? All right, so the next thing is we have our default texture within our render system state, but we need a second, which we're going to call test diffuse, right? So this is actually our test diffuse texture map that we're going to use to render our object with, right? So you can think of this as just a the actual texture that would be rendering or loading along with an object that should be assigned to that object, and it's going to look something like this, right? So we're just going to call this test diffuse for now. And in fact, I'm going to wrap this also in our to-do temporary comments here. okay, just so we remember to come back and remove that later. So the next thing that we're going to do is we are going to create a couple of sort of private methods for the creation and loading of a texture, at least locally, right? So what we're going to have here is one method that says create texture, and it takes a pointer to a texture. And all this does is zero out the memory of that texture, and then assign texture generation to invalid ID, right? So this way we actually have a texture there. None of its data is actually filled in yet, so it's technically considered unloaded, but it's actually technically created and ready to be loaded, if that makes sense, okay? And then we're also going to define a method which is called load texture, which is going to return a Boolean as to whether or not that texture was successfully loaded, right? And this is going to take in a texture name, which we're going to use to build out a file path. And then it is also going to take a pointer to a texture, and that pointer to the texture will actually be updated, okay? So the very first thing that we're going to do is we are going to define some fields that we need to load the texture. So we're going to have a format string here, and this is going to start off as just saying assets textures, right? So that's our layout up here, right? So we have our new textures, right? And that's where they live. And then we'll have one string and a second string, so it'll be file name and then extension, right? We're going to say that our required channel count is 4. That's going to be our RGBA, because we're going to want to have 4 channels worth of data regardless of what the actual image provides us, which might only be 3 if it doesn't have an alpha. Next thing we're going to do is we're going to call this STBI set flip vertically on load to true. Now, one thing that I don't think I've mentioned previously is most images are actually stored in a format where the image data is stored upside down. So technically the image loads from the bottom up, and so that means that when you load in the image, it would actually appear upside down unless you actually set this to true, right? So this essentially flips the memory in the array to be the right side up, okay? So that's a common gotcha with texture loading. If you're not familiar with that, is a lot of images do actually store that upside down, image formats rather. Next we have a character array, which is the full file path. It's limited to 512 characters. Again, this is just temporary code, so I'm trying to keep this as simple as possible, okay? So the next thing we're going to do is we're going to call a string format. We're going to pass it the full file path, right? So this is the destination buffer, the format string, which is here. And then we're going to pass it the texture name, and we're going to pass it PNG for the extension, right? And again, I have here that we should try different extensions. Basically what we should do is we should probably loop through a few common extensions that we support and say, hey, does a PNG file with this name exist? Does a JPEG file with this name exist? Bitmap, and so on and so forth. But for now, we're not going to bother with that. We're just going to keep this simple. And then when we implement our resource loader, we'll get a little bit more fancy with it. All right, so the first thing that we want to do in terms of actually loading is we want to use a temporary local texture to load everything into, right? And then we are going to call our STBI load function, which is actually what opens up the file and loads the data. So it returns an unsigned 8-bit integer array. So we're saving that off to a variable called data. We pass along our full file path. We pass along a pointer to x, y, comp, which is actually the channel count, and then the required channel count here is the last variable, right? So this will actually tell you how many channels are in the texture that you loaded versus what the actual required is. And then this will go ahead and convert that to that format as needed, okay? And so here what we've done is we're taking the address of the width, the address of the height, the address of the channel count within our temporary texture, and we're passing pointers to those things. And we have to have this cast to I32 because these are U32s right? And I don't believe this ever actually sets that to a negative number. So this should be perfectly safe to do, okay? All right, so at this point, either our data is going to be loaded or it's not. However, before we move on, one thing that is important is, since we are actually requiring this channel count of 4 to be passed through, that is the format that our data is going to have. So rather than saving this out, right, we're going to overwrite the channel count in the texture with the required channel count, okay? So for debugging purposes, this might be helpful to actually maybe save this off separately, but for now I'm not going to worry about that. Okay, so the next thing that we're going to do is, obviously, we are going to check to see if data exists, because if for some reason stbi load fails, this is actually going to return a null pointer, and if that happens, we need to actually handle that gracefully, okay? So in our case, we're just going to check to see if it exists. If it does, we are going to save off the current generation of the texture that's passed in, right? Because this load texture is actually going to also accept textures that have already been loaded and replace out what is in that texture. So what we're going to wind up with is the ability to pass either an unloaded texture or a loaded texture here. And either way, it will swap out what is in that texture with the new version of it, right? So the first thing we need to do is take a copy of the current generation of that texture, whatever that may be. If it's an unloaded texture, it'll automatically be invalid ID. Otherwise, we may have a valid ID there, or a valid generation number, and we need to save that off. So we go ahead and do that, and then we set the texture generation itself to invalid ID temporarily. This way, if we happen to be trying to use this texture while we're actually loading this stuff up, what it'll do is it'll actually flip it to the default texture for a second and use that instead. Shouldn't happen, but it's sort of a safeguard just in case that's ever needed. So the next thing that we'll do is calculate the total size of the texture, which is the width times the height times the required channel count, okay? And we're going to use that to check all the pixels to see if there are any, if there's any transparency in the image whatsoever. This isn't super important for us to know now, but it will be important later on when we actually have to deal with transparent objects and object sorting, right? And so the way that we do that is we basically just loop through all the pixels and look at the alpha channel, which is going to be the 4th pixel, right? And we say if that's anything less than 255, if the alpha transparency, if the alpha channel pixel is anything less than 255, then it's even slightly transparent, then that means that it is a transparent texture, and we can set that and break out, okay? Otherwise, it just defaults to false, right? Now, the next thing that we should check here is the return of a function called stbi failure reason. So this will be this will return true if there was any sort of error in the loading process. So we should go ahead and check that. And here is where we basically just print that out, right? So we say we failed to load the file, right? And then we print out the actual error that is given by calling stbi failure reason, okay? All right. So the next thing is we need to acquire internal resources and upload it to the GPU, right? So that is our call to renderer create texture, right? And actually, I have default here. This probably should just be texture name instead. Let's go ahead and swap that. And we're actually also going to switch this to true, right? Because we want to eventually auto-release any textures that we load this way. Unless we specifically, for some reason, don't want to do that, right? So maybe we need to pass a Boolean here for that, but for right now, I'm just going to flip that to true. Again, we don't have that implemented yet, so that may or may not change. Okay, so we pass the temp texture width, height, and channel count. We pass the data, and then that last false is this has transparency. That is actually should be this. Has transparency, right? So that was hard-coded false, definitely should not be. And then we pass the address of temp texture, right? And so it basically uses this temp texture to create all of the internal resources against, okay? And the reason that we do that is because, if you recall, this can be a loaded or unloaded texture. So we don't want to immediately do it against this and clobber what's there if it might fail or not be ready in time, okay? So what we do next is we take a copy of the old texture, right? So we just dereference t and store it in a local texture variable called old. And then what we do is we take the temp texture and we apply it or assign it to the value that the pointer is pointing to, right? So we dereference t again, and we say that's equal to temp texture, right? So that creates the swap. Next, we destroy the old texture, right? So that we clean up any memory there and we don't leak resources. And then next we need to reapply the generation, right? So if the current generation was invalid ID, like if the texture that was passed here is unloaded, then all we do is we go ahead and flip that to 0, right? Because 0 is a valid generation, it's the first generation. Otherwise, if it was already a previously loaded one, then we take the current generation, which was the previous generation value, add 1 to it, and assign that to generation, okay? Finally, we go ahead and we clean up the data. So we call stb image free against data, and we return true. Technically, that means that the data in the image is thrown out as well. So we may or may not want to do this, but for now, I don't want to leak the memory. So for now, that's what we're going to go with. All right, so this is all if the data is actually loaded, right? If the data is not loaded for some reason, then what we're going to do is we're going to say else, and then we're going to go ahead and do this one more time. So our STB failure reason, if we have one of those, we're going to do that, and then we'll go ahead and return false here, okay? And that is our image or our texture loading, right? So now we can just call load texture and not have to use this directly, okay? It just kind of handles it for us. Okay, so that is a decent bulk of the work, okay? So the next thing that we're going to do is in our renderer initialize, right below our renderer create texture, remember we call this directly for the default texture, and we're going to leave this as is. But we are going to manually set the texture generation on it to be invalid ID. Since this is the default texture, this technically shouldn't have a generation, right? And this automatically assigns a generation of 0, so we need to actually flip that back manually to invalid ID, okay? This is not something that we do normally, but because this is a default texture, we want to treat it a little bit differently. So right here we have something to create our test diffuse texture. So we're going to call our create texture, which again, if you recall, is just simple. It just zeroes this out and then calls and then sets the generation to be invalid ID. Okay. So we need to create our test diffuse texture, right? And then I have to do load other textures here. This is for the other defaults that we're going to need. So since we have a render destroy texture for our default texture, we should also do that for our test diffuse, right? So we don't get an error regarding that. And then we'll come down here to our renderer draw frame, and we're going to switch this from default texture to test diffuse, right? So that we're actually using that texture instead. And again, right away this won't be loaded, so it'll actually fall back to using the default texture, okay? All right. So I think, at least for the short term, this should go ahead and build. So let's go ahead and build this and just do a sanity check, right? We're not actually loading up the texture yet. but I just want to make sure that it still runs as is. Okay, so we'll go ahead and run. And I missed something, evidently. All right, so let's see, what did I miss? We did not update this descriptor set. Okay, oh, that's probably something I missed in the shader logic, I'm guessing. In renderer system initialize, right underneath where we set the state pointer to state, we actually need to take a pointer to any default textures that are used in the back end, right? So we actually didn't set this yet, so this was actually null, right? So that is why that didn't work. So let's go ahead and build that, and we'll run again. And scroll past all this because that was from the last run. And now we're good to go, right? So if I move this up here, we can still see that we have our texture. So nothing visually has changed yet, but we're getting to that now. Okay, so the next thing that we want to do is we need to go ahead and set up a way for us to be able to load our textures sort of on demand, right? Because that's going to be the real litmus test for everything that we've done so far. So to do this, we are going to need to use our event system, right? And what I've actually decided is we have these sort of predetermined event codes here, and we're going to create some new ones specifically for debugging. And this is going to be a range, and it's basically going to be from 16 all the way down to 20, so the hex codes for that. And we have event code debug 0, 1, 2, 3, and 4, right? So we have 5 of these, should be enough. And we'll wind up tying these to various things as we develop the engine. And then when we don't need them anymore, we can go ahead and free them up. So I'm just going to create 5 of these. We're only going to wind up using this first one for now, but that'll give us a new code to actually be able to use without having to create a temporary one specifically for this, okay? So that is the event. The next thing that we're going to want to do is we are going to want to create another temp block in our renderer front end. So we'll come down here right below our load texture. So if we go to the end of that, right here, I'm going to create a new temp block, right? And we are going to add in a event handler. Okay, and this is going to be just event on debug event is all we're going to call it. And it's not going to do anything special. It's not even going to read any of the context data or the listener or any of that. So the way that this is going to work is every time this event is fired, it's going to cycle through each one of these. And the way we're going to do that is we're going to have an array of names, right? So cobblestone, paving, paving 2. Again, you change these out for whatever you actually want to use if you're using different textures. And then we're going to have a static integer called choice, and we're going to start that off at 2, right? And so we're going to use this choice to index into this array. So this is 0, 1, and 2. And we're going to start this off at 2 because every time we call this, we are going to increment this. And then we are going to mod it against 3 to wrap it back around. So what this is going to do is this will start off at 2 as the very first time. We'll increment it to 3, and then we'll mod it by 3, which will wrap it back around to 0, right? And then every time we call this, it'll just 0, 1, 2, 0, 1, 2, 0, 1, 2, okay? And then what we'll do is we will load up the new texture by using the choice to index into the names array. And we will pass it a pointer to the test diffuse texture. And then we're just going to return true to say that this event has been handled. Right, so this is going to be the callback that we're going to use as our event handler, right? So now that we have that set up, we actually need to go ahead and register for the event. So again, right here below our state pointer equals state, I am actually going to put our listener right here. So we're going to go ahead and register for the event code debug 0. We'll pass it the state pointer as the listener, doesn't really matter. And then we're going to say our handler is going to be the event on debug event. Okay. All right, so that is the registration of that. One more thing that we need to do is, because we are registering for an event here, we need to actually unregister for it when we shut down. So that's going to be the first thing that we're going to do whenever we go to shut down. So we'll say event unregister, and it's basically the same call as before, all the same parameters, it's just unregister instead, okay? And that actually should do it for everything in the front end, right? That should pretty much handle all of that for us. So the other half of this is actually going to be in our game, and I know it's been a while since we've done this, and by a while I mean one video. So, whoops, that's tests. So we want our test bed game.c. Obviously this means that we're going to have to go in here and include our core event.h so that we can actually trigger the event. And we're going to put in another temp block in here. I'm actually going to go right into the game update loop, and right after this M, where we're checking for allocations, I'm going to go ahead and put in a new check here, right? And we're going to use the T key for this. So if the T key is when it's released and it was previously down, we're going to go ahead and output something that says swapping texture. We're just going to pass an empty context, and then we're going to fire our event, which is event code debug 0. We're going to pass the game instance as the sender. Doesn't really matter because we're not using it. We could pass 0 there, but just as an example of maybe something we'd want to pass there, right? Doesn't really matter. And that should be it for the event hookup. So what I'm going to do now is I'm actually going to go ahead and run the post build, which is going to copy our assets over, right? And again, this copying asset thing is temporary. We're not going to do that going forward, but for right now, until we actually get our resource system in place, it's just something that makes this a little bit easier, okay? So I've built this. I'm going to go ahead and run, and I'll move this up here. And let's just move our camera a little bit closer, right? And I'll go ahead and hit T. And what do you know? We have our texture being loaded on disk, and it is actually loaded and assigned while the application is running. So I can press T again, and we get the next one. I press T again, and we get the next one. And I can actually keep pressing this, and it will keep loading it, right? Which is obviously we don't want to keep loading this off of disk every single time, but as you can see, we could very easily adapt this to a hot reloading structure where anytime the file changes on disk, we could actually just call this code and it will just work, okay? So anyways, that's going to wrap it up for this. So thank you guys so much for watching. If you haven't already, consider subscribing. Click the little bell notification icon there to get notified as to when the next video in this or other series drops. And I will see you guys next time.